How you doing, everyone? I'm Sean O'Kane with ChipEstimate.com. We're here at the Design Automation Conference, the 55th Design Automation Conference in San Francisco at Moscone West. And let me tell you just a little bit about ChipEstimate.com. We're an IP portal, an ecosystem comprised of over 200 of the world's largest IP suppliers and foundries, and we're all working together to help the design community become more successful and profitable by searching and exploring the most up-to-date silicon-proven IP available on the market today. That's all listed on ChipEstimate.com. And with me today is Ron DiGiuseppe. He's a product marketing manager with Synopsys. Ron has been with us before in past design automation conferences, and in fact, Synopsys has their complete IP catalog listed on ChipEstimate.com. Our topic today is ISO 26262, the certified IP for integrated ADAS domain controller SoCs. Now I'll explain a little bit. So the first question is, with all the activity around the automotive industry and ADAS, advanced driver assisted systems, or ADAS applications for autonomous driving, has there been a big impact on automotive electronics and automotive semiconductors? Can you tell us what we're now seeing?
Sure. Hi, Sean.
Yes.
Just being here at ChipEstimate.com at DAC. And we all probably know that the automotive industry is going through a lot of changes, especially the electronics. A lot driven by the new applications for ADAS and self-driving, autonomous driving cars. Some of those applications such as automatic emergency braking, surround view, drowsiness driver detection, reverse alert. So the semiconductor industry, automotive semiconductor industry, has really responded by creating new processes and processors for these applications, such as radar, ADAS processors, ultrasonic processors. And the industry's implemented those applications. And a lot's been also driven by the new sensors in the cars, those radar sensors, long range, short range, ultrasonic sensors, LiDAR sensors. But especially image sensors and camera sensors. Some of the newer car models have up to 12 to 18 different cameras in the car, looking forward, surround, in reverse. So the SoCs, the semiconductor chips implementing all those applications, are distributed throughout the car. And some of the late model cars could have up to 100, 150 different MCUs through that car. That's create a lot of complexity, a lot of software. The software lines of codes in automotive is really expanding. So we are seeing some additional evolution within the electronic systems of the car, especially is to centralize those systems and make the complexity of the distributed systems less by integrating multiple applications on centralized ADAS processors. So not only are the new applications driving the electronics within the car, but the centralization of those applications are also expanding the role of those ADAS processors and becoming more complex, because as you centralize the applications, the performance requirements increase, the complexity of those SoC designs increase, and those SoCs are becoming a lot more complex than the more mature traditional automotive chips.
That's a nice segue to my second question, but is it, just as a side comment, but with all those electronics in the car, that needs to be cooled down too. And I understood that they're actually, they took the radiator out of the EVs, but now they're going to put some water cooling system for the electronics.
Well, that's very true, Sean, is that the concerns regarding power is significant in a car. And some people ask me that question is, well, with a 12-volt battery and a gas engine providing lots of power, why is power a concern? And you can imagine these ECU modules have zero or minimal airflow. They're very tightly constrained, so the amount of heat generated by these advanced processors are a real concern regarding long-term reliability and the ability of these systems to extract that power. So power is, even though it's not a battery lifetime issue, it's a heat issue, how to extract the heat of those chips.
So continuing with that theme about more sophisticated automotive chips for more advanced methodology and stitching together IP, the semiconductor industry is evolving, as we know, at a rapid pace, as you mentioned in the very beginning, to innovate more efficient means of processing huge amounts of data. What use cases are required, and I think we touched on that, for the new architectures?
Well, a good example, I think, is Audi's new centralized ADAS platform. It's called ZFAS. It's publicly information available. And that integrates multiple ADAS applications into a single platform. And that platform is composed of 4 existing chips from leading industry automotive semiconductor suppliers. But as these platforms continue to evolve and integrate, those processors will have to also innovate. And so what we're seeing is these centralized multi-domain ADAS controllers need multiple 64-bit processors. These applications will have to be run in virtualized applications, multiple applications at the same time, so hypervisor technology is needed. They'll all need external DRAM, so the amount of DRAM is increasing, and that needs to be automotive-grade DRAM. It can't just be consumer DRAM that you would find in your smartphone. So such technologies like LPDDR4 and LPDDR4X are required for the advanced ADAS processors.
So that's the special IP that is needed for these SoCs?
It's one type of IP.
Okay.
It's only one type of IP. Also, as you can imagine, as these applications become more centralized, but the sensors are also distributed throughout the car, the amount of traffic over the in-car network will also increase. So we're seeing a lot of adoption of Ethernet AVB and the new standard called Ethernet Timing Sensitive Networking. Other high definition display technologies are needed for the infotainment console and the instrument cluster. So that's also driving the newer standards to be adopted by these SoC processors.
And what is Synopsys doing in this space to help automotive SoC designers?
Well, so we touched on this a little bit. Automotive is a special application space. Those systems and the chips going into the systems, they have to operate for up to 15-year product lifetimes. So the design of the IP blocks that go into these automotive chips have to be very robust. It's not just your standard consumer IP. We need to design it based on long-term reliabilities and low defect densities. We have to look at electromigration issues, transistor self-heating issues, transistor aging issues. So you really have to use robust design techniques to implement the design. But it's not just designing for automotive conditions. It's these ADAS applications are also safety critical. And that's where the standard ISO 26262 comes into play. You have to comply with the robust design practices that ISO 26262 requires, such as creating safety plans, defining what the safety features of your products are, having fault injection scenarios, and doing an analysis of what happened to your products if there is a fault that may develop sometime down the road.
Right.
So along with designing according to ISO 26262 compliance, IP providers need to implement those safety features that are being demanded by these customers going into these safety critical applications, which we all know ADAS and autonomous driving, it's safety critical. So the IP going into these chips and IP like from providers such as Synopsys, who has a broad range of automotive IP, have to implement specific safety features to comply with the different safety levels, the ASIL levels of the ISO 26262 standard. Features like protecting all the memories that are used for FIFOs or buffer memories, they should all have ECC protection. And the data path through all these interfaces, they should have parity protection or inline ECC protection. So these are examples of functional safety features that should be added to products that go into safety critical ADAS processor semiconductor designs.
Thank you. This was good. This is a good conversation.
It's an exciting time to be in the automotive industry because there's a lot changing, and it's filtering all the way down to the semiconductor designers and the IP providers that provide IP to those semiconductor designers. So it's exciting.
Yeah. Thanks for being here with us. For Ron DiGiuseppe with Synopsys, my name is Sean O'Kane. We'll see you next time on Chip Estimate TV.
Thanks,
you.
Sean.
Thank
Appreciate
you,
it.
Ron. All right.
Thanks.